All right, guys, how you doing? I am gonna go through a little, just tutorial here real quick. Oh, get this out of there. So I'm gonna go through a little tutorial. So we're gonna calculate the speed. So we got an electronics factory, and in this electronics factory we have a ramp, and on top of that ramp we've got a cabinet or a box. Okay, and that box will slide down in this direction. Will slide down the ramp. Okay, so if here's the ground, our boxes slide down the ramp. And what do we know about this box right here? What kind of energy does this box have? Well, we know that it's got a height, right? It's got a height, and we have an angle here of 30 degrees. So if it were to slide down this, what would it do? It would start gaining speed. Then at the bottom right here, we would have a height of 0 and a kinetic energy that would increase. So right here, what kind of energy we have? We have only potential energy. So initially we have potential energy, and then finally we have a height of 0, so we've got all kinetic. So the sum of our energy, our total mechanical energy initially, is going to equal our mechanical energy finally. So the sum of my KE initial plus my PE initial, is going to, that's an I, equals my KE final plus my, that's a plus, my PE final. So my initial plus initial equals final plus final. So the sum of our energy is going to be the same. As we know up here, initially we're not moving, so we can get rid of our kinetic energy. So all we have is initial gravitational energy, and that's going to equal my final kinetic energy because we're at height equals 0. Since we're at height equals 0, we have no potential energy. So initial potential equals my final kinetic. Okay, in order for us to solve for initial potential energy, we need to do mass times gravity times height. And to solve for final kinetic, we do 1/2 mass times velocity squared. So if we look at this, if we look at our cabinet here, it slides down this 30-degree incline, and it slides a distance. So this distance right here is 16 meters. So what we need to do is we need to figure out what height this thing is at. So once we figure out the height, then we can figure out how much potential energy it has. So how do we solve for the height? Well, if we look here, we have a right triangle, this being my 90-degree angle, and this is my opposite side, and in this case my opposite side is my height that would fit in right here. So I have to figure out what this height is. And we know it's the opposite side, so since it's my opposite side, I have to use sine. In order for us to find this height, our height equals 16 sine 30. And if you just make sure that you have your calculator in degrees. So if we plug this in, we end up getting a height of 8 meters. So 16 times the sine of 30. Sine of 30 happens to be 1/2. Sorry about this. Yeah, 16 sine 30 equals 8 meters. So we get a height here of 8 meters. So we're at a height of 8. So we can plug that in here. Equals. So mass would be 10. Actually, we're not even looking for that. Well, so before that, we know our height. We're looking to calculate the speed. So we're looking for the speed that each cabinet has. And we've got speed right here. So algebraically, I can cancel out mass. So if I divide mass on both sides, mass over mass is 1, so this cancels out. So I'm left with gravity times height equals 1/2 velocity squared. If I wanted to solve for v, I multiply both sides by 2, same old story. So I'm getting 2gh equals v squared. That's an equal sign. And we solve for v, so v equals the square root of 2 times gh. So that's how we solve this problem. Okay, we don't even need the mass yet. So this is what we're looking for. We're looking to solve for v. So v equals square root of 2gh, so 2 times, move this over, Square root of 2 times 9.8, which is 19.6, times 8. So I plug that into my calculator. So we end up getting the square root. So V equals the square root of 156.8, or 12.5 meters per second. So here's our answer. Sorry about the units being so far off. 12.5 meters per second. So there's our answer, and that's how we do A. Okay, this is how we do B. So everybody got it? Good, since I can't hear you, just assume. All right, here we go. So what kinetic energy would that cabinet have under such circumstances? So now we're looking to find what the actual kinetic energy would be. And we know that kinetic energy equals, half of our mass times our velocity squared. So let's see. So K E equals 1/2 of our mass, which was 10, times our velocity, which was 12.5 squared. So 12.5 squared equals 156.25. Multiply that by 5. So 156.25 times half of 10, which is 5. So our kinetic energy equals that. So our kinetic energy then is 781 joules. Okay, and if you remember, we did our PE equals mgh at the beginning, so our mass was 10, gravity was 9.8, and our height was 8 meters. So if you multiply these together, you end up getting, so 98 times 8, you end up getting 784. So if we look, our answers are both very close. So this 3 joule difference becomes because we rounded what our velocity was in the last problem. So we see that our kinetic energy at the end equals our potential energy at the beginning. So we've solved the problem, and now you see that energy is conserved. All right, there you go, guys. Anything else, we'll talk about it Monday.